Hi there. Today we're looking at all things linear. So everything you have learned in the past about linear functions all crammed into one lesson. So let's move. Here we go. So how about finding slope from a graph or graphing lines, knowing the difference between horizontal and vertical lines. All of that has to do with the graphs of linear functions. We'll also look at linear functions numerically. Can you write equations if I give you all the numbers, ordered pairs, that kind of thing? Can you write an equation? Can you find the distance between two points or the midpoint? Do you know those formulas? And then algebraically, we'll look at just solving a linear equation. That's what this video will cover. Let's start graphical. Do you know your slope formula? Can you find the slope? Well, to be able to do that, you're going to need to know that your slope formula is y2 minus y1 over x2 minus x1. Using that formula, if I give you a couple points, we can go find the slope. So I'd have a -2 minus -6 over -3 minus 4. Change your signs. That becomes a +4 over a -7. That's the slope of the line between these 2 points. Let's talk about actually graphing those lines. This particular equation that I have is linear, but it's not in that nice graphing form. The graphing form you're probably familiar with is slope-intercept form. These are the formulas that you should know, and if you don't, take note of those. In order to graph this line that I gave you, it would be nice if it was in slope-intercept form. Let's go ahead and isolate the y so that it is. I'm going to have a -5y. I like to put the x term first, so it looks like mx plus b. Divide by your -5. This equation in slope-intercept form, y equals 3/5 x minus 2. This is the equation then that I want to graph over here on my graph. Remember that the b value is your y-intercept, so my y-intercept is -2. The 3/5 is my m, or my slope. That would be your rise over your run. On your graph, you're going to rise 3, and you do this from your y-intercept. I'm going to rise 3, and let me show that here. So I guess 1, 2, 3, and run 5. 1, 2, 3, 4, 5. So we would put a point right there. I missed it, sorry. Down one more. Just like you can rise 3 and run 5, you could do both of those negative. You could go down 3 and left 5, and that should still line up. Once you have your points, go ahead and draw your line and put arrows to show that it continues. That's not the only way to graph a line, but probably the one you're most familiar with and the one that uses your slope-intercept form. There's a couple special types of lines, and those are your horizontal and vertical lines. And they're supposed to be easy. When you look at these equations, they look super easy, but sometimes that super easy stuff is different, and then we forget what it means. HOIVUX is just a little acronym to help you remember when you come across something like this, keeping track of what's horizontal and what's vertical. Your teachers in the previous years maybe have taught you HOIVUX, maybe not, but it's just an acronym. Horizontal lines have a 0 slope, and their equations look like y equals some number. And so it'll be a horizontal line that crosses the y-axis at whatever number is sitting here. Vertical lines have undefined slope, and their equations are x equals some number. So that's going to be a vertical line crossing the x-axis at whatever number it equals. If you look at the two that I gave you, this one here is an x, so that's VUX. It's going to be a vertical line. It crosses at -2. The second one is a y, so that's hoi, and so that's a horizontal line, crosses the y-axis at 4. That's not real hard. The thing you just have to remember is when you come across it, after you're sitting there doing slope-intercept form over and over, and then you get one of these thrown at you, you have to remember that hoi vux. Those are horizontal and vertical lines. Writing equations. Now we're starting to get into a little bit more challenging problems, but to write your linear equation, how you do this can vary. I think I'll probably show both ways just because I think we have a lot of teachers that teach slope-intercept form, and we have a lot of teachers that teach point-slope form. I don't care which method you use, you just need to know a method and be able to do it. The first thing to write this equation that goes between these two lines is to find the slope. So using that slope formula from previously, or that previous slide, I'm going to do y minus y over x minus x. Change your signs. Looks like we're going to have a positive 4 over a negative 6. Our slope would reduce to negative 2/3. So regardless of what method you like, you have to find your slope first. Now let's go do slope-intercept form. If you're going to choose this method, you're going to replace the m in the equation with the m, or the slope, that we have previously found. You're going to pick one of these 2 points, and remember that that's an x comma y. And you're going to replace the x and the y in the equation with these x and y's. Now since I went ahead and wrote that, I'm going to use this point. You could have just as easily chosen the other point. Doesn't matter. To replace all those variables, the y is going to turn into a negative 6. The m is the negative 2/3. The x is 3 plus b. That's my goal. I'm going to go find b. Think of this 3 as a 3 over 1, so that these 3's would cancel nicely for you when you're multiplying. Negative 6 will equal a negative 2 plus b. Add the 2. B is equal to a negative 4. Once you know the b, and you previously had found the m, you should be able to write your equation in slope-intercept form. Y equals negative 2/3 x minus 4. There's the equation of the line that passes through those 2 points. All right, if you're happy, you can skip this next part and keep going. If you want a review of point-slope form, I'm going to go into that now. Point-slope form is y minus y1 equals m times x minus x1. And you start off similarly to the slope-intercept form, where you are just replacing some of those variables in there. I'm going to get rid of the x1 and the y1 from this point. I'm going to get rid of the m from here, and I'm going to leave the first y and x as a y and an x. You're going to change this to a y plus 6, and you're going to distribute your negative 2/3. And again, here's how that's similar to the previous one. Here's where you're taking that negative 2/3 times a negative 3 over 1, which is going to turn into a negative times a negative will be a positive. The 3's will cancel. It'll be a 2. Your last step is just to move that 6 to the other side, and you've got your equation in slope-intercept form. Notice it's the same thing I had on the previous method. Doesn't matter which way you do it, just go with it. A couple of the other formulas that you're going to want to remember: the distance formula and the midpoint formula. Distance, big square root x2 minus x1 squared plus y2 minus y1 squared. Let's use that with these 2 points. I'm looking for the distance between these two. We just start plugging in numbers. The distance is going to be the square root. x2 is a -3 minus x1, which is 4. I'm going to take that and I'm going to square it. And now I do it with the y's. y2 is a -2 minus y1 is -6, and that's all going to end up squared. -3 minus 4, that's a -7. And -7 squared is 49. Plus, I'm going to do a change here. So now that becomes a -2 and a +6, so that's 4. And 4 squared is 16. You add your 49 and your 16 to get a 65. So the distance between those 2 points is the square root of 65, which should be just a little bit bigger than 8 if you were to get a decimal. As far as reducing that radical, the square root of 65 does not reduce. Typically, I'll just leave my distance as a radical, like that. Let's try midpoint. A different formula for midpoint. The midpoint is actually an ordered pair. It's the point that falls in the middle of these two. I always think of it as finding kind of like the average of the two. I'm looking for the middle of it or the average. So you do it as an average, but it's an ordered pair average. And to find the average of the ordered pairs, I'm going to work with my x's first, and I'm going to add my x's together and divide by 2. Then I'm going to add my y's together and divide by 2. Just like I'm finding an average of the x's and average of the y's. In this case, I'm going to have 4 plus -3 all over 2, and -6 plus -2 all over 2. That's going to simplify to a 1/2, and this is going to be a -8 over 2, which reduces to -4. The midpoint between these two comes out somewhat nice, somewhat not so nice. So, all right, know those two formulas, distance and midpoint. The tricky thing is keeping track of when do you add, when do you subtract. You got to know the difference. Now, the algebraic way of looking at linear functions is to just do some solving. So I thought I'd give you a crazy equation here and see how you do at solving and just trying to get the x by itself. I kind of like fun fonts, and so you can see here I have, this is an x. It looks kind of like a q, but I mean like a k, but it's supposed to be an x. But regardless, whatever variable you're using, can you solve this and get your x isolated? Several steps, but it shouldn't be too hard for us. First thing we're going to do is distribute. This becomes 3x minus 12 plus 8x. On this side, I'm going to distribute this negative. You have to remember that that goes to both of those. It's going to be a 2 minus 5x minus 4, and all of that is still over 6. The next thing that I would do is go ahead and condense like terms on each side. On the left, I have a 3x and an 8x. That would get me an 11x minus 12. On this side, I have the 2 and the -4. It's still over 6. You may choose to reduce these fractions or separate that fraction, but it's going to be ugly. It doesn't divide by 6 nicely. A better option would be to choose to multiply both sides by 6. On the right side, those 6's just cancel. On the left side, you're going to distribute. Now this looks a little bit more like something you've probably seen. Let's add the 5x over to this side to get a 71x. Let's add the 72 over to the right to get 70. Divide by 71, and you've got your final answer. X is equal to 70 over 71. No promises they're going to come out nice. That's what it is. Let's try an application of a linear equation. In this example, it says a business purchases a piece of equipment for $875. And then after 5 years, that equipment is outdated and it has no value whatsoever. Write the linear equation giving the value of the equipment during the 5 years it will be used. I like to kind of visualize what's going on here. So I'm going to start with a graph. And think about this. What are your two variables in this? Well, you're talking about time and you're talking about the value. We typically put time on the x-axis, so this will be time, and the value is the y-axis. And you know a couple pieces of information. You know that you purchased the equipment for $875. Right here at time 0, this equipment is worth $875. But then it gets used and it's decreasing in value, and the next thing that you know is right here when the value has dropped off to being worth nothing. Basically what we have been given is two ordered pairs. This ordered pair right here is after 5 years the value is 0, and this ordered pair is at time 0 the value was $875. This is a problem just like the previous one where they've given us 2 points. We have to write the equation of that line. These are actually nice points because you got the zeros in there. I also wanted to graph this so that you could see this ordered pair here. Remember that you can find your y-intercept anytime your x value is 0. Plug 0 in for x, and that's your y-intercept. We don't have to go to a lot of work to find the b, the y-intercept. We know the y-intercept. It's 875. We do still have to find the slope. But we're kind of at this stage now. I think we can do some mental math. The slope is equal to y minus y. I can do that in my head. That's 875. Over x minus x. That would be negative 5. Which divides nicely to a negative 175. We have a slope of negative 175. We have a y-intercept of 875. The equation of this line is, and you're putting it in slope-intercept form, but we aren't using x and y. We're using letters that mean something. So for the y, it's really the value. I'm going to write v equals negative 175 x, but I'm not using x, I'm using t for time, and then the y-intercept plus 875. There's our linear equation. Now that's not rocket science, that wasn't that hard. One of the things that in PreCalc we're going to be doing is understanding what we just did. Instead of just plugging and chugging through it, do you even know what we just did? What does this mean? What does the 875 mean? Well, the 875 is your y-intercept, but more importantly, in this problem, this is the initial cost of the equipment. And how about the negative 175? What does that mean? Well, the negative would tell you that it's decreasing, the value is decreasing. Think of it as a 175 over 1. The top, the numerator, is the change in y. The denominator is the change in x. So the value is going down $175 for each 1 year. That's what it means to interpret the slope or the rate of change, which is what you'll be doing on your assignment. Let's write the equipment. And perhaps a nice word here would be depreciates. Instead of going down, we'd say it depreciates $175 per year. Understand what that equation is telling you. Now we're going to try one more application, but this one is kind of getting to know your graphing calculator. This video is not here to help you learn your graphing calculator. I have other videos, or you can always YouTube how to make a scatter plot on your calculator. Be sure to specify what type of calculator you have, because different calculators are going to do different things. I'm going to assume for this video that you can make a scatter plot. What you would need to do, I guess let's go through what this problem is. It's a different problem. This is a supermarket chain, and they are conducting an analysis on their store brand of donut-shaped oat breakfast cereal. Okay, so that's the generic Cheerios. They've got their own Cheerios they're selling, and they're looking at what happens. It says the chain sets various prices for its 15-ounce box at different stores. Then it uses the data, using the data, the researchers project what the weekly sales will be each week. Let's look at the table. Let's look what's going on numerically. You make the cereal cost $2.40. You should be able to sell 38,000 in some boxes. But if you increase the price, what do you suppose that does to your sales? Yeah, they're going to go down. Keep increasing the price, sales keep going down. Is that bad? Well, I don't know. Not necessarily. Yes, your sales are going down, but aren't you also charging more for the ones that you do sell? Maybe you're making more money. Who knows? Well, that's a different problem. That's actually a problem for tomorrow. The relationship as far as talking about profit. So we're not talking profit today. All we're talking about is the demand for the cereal on your sales. As you raise the price, we notice that the demand goes down. That actually has a linear relationship. So what I need you to do is pause the video while you get a scatter plot drawn. This information here, this table, should go into your list. So real quick, you're going to hit Stat, Edit, fill in your list. You need to fix your window so that it matches this data and get the graph shown. The next thing you want to do is run a regression. So let's go ahead and pause the video right now and get all of that work done. Get your scatter plot, run a regression, figure out how to do that, and then we'll follow up. Pause the video. Now that you have the graph of that data, let's talk about what that means. Using your graphing calculator, plot the data should look like this. Find a linear model for the demand as a function of the price per box. If you run the regression on that, the equation that you should be looking at is y equals negative 15,350, and I'm going to go ahead and just round that off to 59. I know it's not exactly but I'm going to round it to that because that's the number of cereal boxes. And then I'm going to add to that the y-intercept of 73,620, and I'm going to round that up to 23. There's the equation. Typically I like to have a decimal or two in there, but I'm going to go ahead and leave it at that, rounded off. Let's interpret what that means. This says interpret the rate of change. The rate of change is your slope. Remember, think of that as over 1. The numerator is the change in y, the change in sales, how many they sold, over the change in x, which is the cost. If you look at your units on this, this was number of boxes, this was in dollars. The rate of change then would mean that the number of boxes sold Since it's negative, it decreased 15,359 for every $1 of price increase. Now I know that the table looks like it's going up by 20 cents, but your units are in dollars, so you have to kind of think about that. It's 15,000 down for every $1 of price increase. Let's interpret, I know it's not here, but let's go ahead and interpret the y-intercept while we're at it. This right here, remember that the y-intercept, if you were to graph your line, it would go somewhere like right through here. And this y-intercept right here is the number of boxes sold if the cost was way back here at 0. So that ordered pair right there is like 0, 73,623. If your cost is 0, basically you're just giving the boxes away. So if you're standing at the door and they're free for the taking, you're going to be able to get rid of 73,623 boxes. That's what the y-intercept means. Last question. Use the model to predict weekly sales if the price is dropped to $2 or raised to $4. You're basically just taking this $2 and plugging in for X, see what you get. Plug $4 in, see what you get. On your calculator, I like to use the, sorry, gotta turn my calculator on. I like to use the value option, which is second trace, number 1, and you just type in an X value and it's going to give you back the Y value. Now, it would be exact because it has decimal values. If you used the equation that you have that I've written where I didn't have any decimals, then it might be off a little bit. We're not going to nitpick that. I guess I don't have the equation in there, so I'm going to go ahead and just type in then in my calculator negative 15,359, and I'm going to take it times $2 and then add the 73,623, and I end up with, so for $2 I'm getting 42,905 boxes sold. If I changed the 2 into a 4 and I raised the price to $4, I'm going to sell a lot less boxes. I'm only going to sell 12,187 boxes. There you go. That's linear functions in a nutshell. Good luck.